Hey guys, so I'm here today to share with you how to use the oil immersion technique in microbiology. So my microscopes are a little bit different than what you may have used in the past. So these microscopes are different in that, number one, they have what's called a mechanical stage. So you can see right here, when I go to place my slide on here, I'm going to use this lever over here. Can you see where my finger is? Like this, okay? So from here, and so that's where I'm going to put, it's not a stage clip, so don't try and put the slide on there and then lift that thing back up and place it on top. That'll break it, okay? So when it is secured in place in that right angle in there, it gives you the opportunity to use both of these knobs. So if you're like me and you have a little bit too much coffee in the mornings and you're a little shaky, this is a lot easier. So what one knob does is it moves it up and down, and the other knob then moves it side to side. So that's how you use what's called a mechanical stage. And these are fairly expensive, so try and be super careful with them, okay? To begin with, we're going to start with the microscope on its lowest power. Now, this is where things get tricky because most people don't understand how to properly determine what the magnification is that they're looking at. So what I'd like for you to do, and I'm going to see if I can make this work the easiest, can you see the number here on the outside of the yellow objective? So this one right here, there's two numbers on there. There's a decimal place, and then there's a larger number, right, greater than 1. And so if you think about the whole purpose of the microscope, it's to magnify things. So why would the magnification be a decimal? Doesn't that actually make it smaller then? So if you think about it, we're going to use what's called the DIN number. And so on the yellow objective here, our DIN number is 10. So this objective lens is 10 times magnified. The eyepiece is always 10 times as well. So if I'm on the yellow objective, that is for a total of 100 times magnification. Good? So always start on the red. That's our low power. So I'm going to take a slide, and I'm going to go ahead and place it on the stage and release that clip. I know I've kind of got the camera angled up right now, so it's hard for you to see. I'm going to turn the microscope on, and that's maybe the number one thing that people do wrong. They're like, I can't see anything, it's black. Well, you got to turn it on, okay? Make sure it's plugged in and turned on. If you are right-handed, put all of the knobs on your right side. If you are left-handed, then take and flip this around and turn the microscope so that you can work all of the adjustments with your dominant hand, okay? So when I go to look underneath the microscope, I'm starting on low power, and before I even start, I just already did a no-no, is I want to move the center of the slide where I see the stain to the middle, so that way the light is actually passing through the specimen. So now I'm going to view, and I'm going to raise that stage until I see some color. So I can see the color, and I've kind of got it in focus. It just looks like a bunch of pink fuzz in the background. So everything that we're going to be viewing is, to begin with, is going to be stained. So it's going to have either pink or purple, in some cases maybe blue stain. So it should be pretty easy for you to see the color. There are a couple of slides that I have that are pretty challenging because the bacteria are so small that it's really hard to see that color, okay? So I raise it up, excuse me, until I get my low power in focus. I'm not going to move the stage. I'm going to move it to medium power. At this point, I'm probably only going to touch my fine adjustment, and I'm going to continue to focus it until I get it in focus as best as I can. If, as you move up in your objectives in magnification, you find that it's a little fuzzy and you can't really get it to be clear, that's actually called resolution. You should recognize that maybe from common knowledge about purchasing TVs or cameras or something like that. So, you know, like videos, whether it's 720p or 1080p. So this is resolution in terms of microscopy. It's the ability to distinguish between 2 points. So if it's fuzzy and you can't really distinguish between the two, not very good resolution. So if that happens, there's one of two things that you can do. okay? Number one, you might not be on a high enough magnification yet to be able to improve the resolution, but you also might just want to clean the lens. So we have some boxes like this, or there are some individual packets of lens paper. Now this box actually has like pieces, so if you kind of wet your finger and pull it out, it's kind of like a Kleenex box. So just go ahead and take one out. These are going to be sitting on the middle table for you, so if you need one, just go grab one, okay? And then you can kind of take and moisten it. I guess you could use your saliva, but if you use the sink behind me over here, just dampen it a little bit. Go get in there, go ahead and rub right on it, right? Get it all cleaned off. And then as I move up to high power, okay, now it's still kind of fuzzy for me. So I'm gonna try and use my fine adjustment to get it focused. So I've got it as best as I can right now. And this is, our high power is 40 times magnification. So that's for a total of 400. So I'm gonna do something right now with the camera. I'm gonna see, oh, nope, it's not gonna let me switch the view. I was hoping I could switch the view while we were doing this, so that way I can show you in the microscope so that you can actually see what I'm seeing. But I do wanna show you, before I forget, over here on the center table is where all of your slides are, as well as the immersion oil that we're gonna be using, and that's where I'll have the lens paper sitting as well. So here's what you need to do next, okay? 400 times magnification, boy, that's pretty good, but we can do better, because these microscopes actually have a fourth objective, and it's the oil immersion objective. So this one, the DIN number is 100. So 100 times 10, we can go up to 1,000 times magnification, which is really significant in the world of microbes. So what I want to do is I want to keep the area that I actually want to view and focus right at the very center. So the lens itself, right, is kind of concave at the bottom. So that means that you can only focus in on a certain area at one time by raising that stage up or down. So I would get the center of your field of vision in focus, and the outside edges might be a little blurry. Now, what I'm gonna do at this point is I'm gonna take immersion oil, okay? These bottles, the cap, when you unscrew it, has a wand on it, and then the oil will just drip off of it. The other type of bottle that we have, and I've only got a couple of these left because they're actually kind of messy, so don't take these if you don't have to, is this bottle that has the red top. And so it's a squirt bottle. So you just pull the red top off, and then when you tip it over, you can drop a drop of oil. It's called the dropper bottle. And then just pop that back on. So this immersion oil, I'm gonna take it, and now I'm gonna switch the objective so that it's halfway. I'm actually not even all the way on or focused on the slide anymore. If I were to look through the eyepiece, it's black because there's no light passing through. So I'm gonna go ahead, I'm gonna take my drop, I'm gonna place it right on the slide, directly on there. I know it gets a little messy after a while, but then I take the oil immersion, and I'm gonna see if I can get this sideways so that you can see it. I'm gonna slide it into place, and as I do so, the oil makes contact with the lens. And then from the glass, through the oil, through the objective lens, there's nowhere for light waves to bend and get refracted out. So refraction is light waves bending. You've seen it if you shine light through a prism and it creates that rainbow effect. That's kind of what happens. So as the light's passing through the glass in the specimen, the light gets bent, and that's what creates the low resolution. Now we want to increase the resolution because these microbes are so small. So by adding the oil, it's the same density as the glass, and it prevents any refraction of light or bending of light, and it keeps the light waves passing up into the body tube and then up through the eyepiece, so that way you can actually see it and you don't lose resolution. So you keep good resolution, you get increased magnification, all while decreasing refraction. So now, as I look in here, it just looks like a pink blur. So as I look in here, I'm going to focus, and again, only use the fine adjustment. And And at this point, I can see very, very clearly, very magnified, those bacteria. So, increased resolution, increased magnification 1,000 times, and decreased refraction. This oil immersion technique allows us to see things that are significantly smaller in the cellular world, and gives us the ability to study their structure a lot better. Now, how do I clean up? First things first, lower the stage, excuse me, wipe off the oil. If you don't wipe off, excuse me, my goodness, if you don't wipe off the oil every single time, it'll dry on there and cake on, and that's not good. Sorry, people keep walking by my room and I keep seeing them and they must think I'm talking to myself. Then I'm finished with the slide, so I'm gonna pull the slide off, but now the slide has oil on it too. So now I have to take the lens wipe and just swipe it a couple of times and get as much of the oil off as you possibly can. Then you're able to take and put this back in the slide box. The one thing I'm gonna ask is make sure that when you are carrying them from the edges, and when you put them back in the box, make sure you're putting it back in the correct box. I can't tell you how many times people have gone and put them into the wrong one. And then other people are like, well, this bacillus doesn't look like it's supposed to. That's because you're looking at Micrococcus, which should be spherical, not rod-shaped. So double check that, make sure. Hey, you guys, good luck in lab.